This is a walkthrough of problem 2 on exam 2 of module 4 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 2 is, for each of the following circuits, capacitor 1 has a value of 10 microfarads, capacitor number 2 a value of 20 microfarads, capacitor number 3 30 microfarads. With an 80-volt battery hooked up across AB, which capacitors will break down? To start, let's just ignore the breakdown voltage and get the voltage drop across each capacitor if the voltage drop across AB is 80 volts. Let's start with circuit number 1 and get the equivalent capacitance. With the equivalent capacitance, we can get the charge on each capacitor. There's a 10, 20, and a 30 in series. We can get the equivalent capacitance like that. If we add up, we get 11 over 60 microfarads. That's 1 over C equivalent. C equivalent is 5.45 microfarads. So the 80-volt battery behaves as if there's a 5.45 microfarad capacitor up here, sucks the charge from over here, and puts it over there. So now we can get the charge through the battery. Charge is C equivalent times the voltage of the battery. So there's the equivalent capacitance of the whole circuit, the voltage of the battery. So the battery takes 436 microcoulombs of charge from one side to the other side. Each of the capacitors gets this charge. There's a domino effect here when the charge is taken from this side and put on this side. Now we can get the voltage drop across each capacitor because we know the charge on each capacitor and the capacitance of each capacitor. The voltage drop across the 10 is 436 microcoulombs divided by 10 microfarads, 43.6 volts, so that's not going to blow. They blow at 50. The voltage drop across the 20 is less. It's got bigger capacitance, only 21.8 volts, and the voltage drop across the 30 is even less, 14.5 volts. So none of those are going to go. They all survive. Now the second circuit, right away we can see that the 3 is across the battery. It's going to have the voltage of the battery. So as soon as you hook it up, it'll blow. That one's going. So now we can look at these guys. There's a couple of ways to do it. We can get the equivalent capacitance of these two, calculate the charge separated, then calculate the voltage across each of them. But we know that they're going to have the same charge. They're in series. And the voltage drop across the big one is going to be half as great as the voltage drop across the little one. So the small capacitance is going to have 2/3 of the voltage drop. The large capacitance is going to have 1/3 of the voltage drop. The whole voltage drop is 80. So the voltage across the 20 is 1/3 of 80, and that's less than 50. The voltage drop across the 10 is 2/3 of 80, and that's bigger than 50. So that one's going to go. So this one will get 53.3 volts if it didn't blow. It's going to blow at 50. Now when it breaks down at 50 volts, this guy's going to have the same charge as this one did when it broke down, and this one's going to have a voltage of 25 volts across it. And it's going to stay there. There's no place for it to go. So here's the final picture. This guy, 43.6, 21.8, 14.5. And this one blows first, then this one blows. So those two are 0 volts. And this one's 25 volts. The battery can't charge it anymore because it's not connected to it. That's problem 2.